So, hello and welcome to the second lecture on probability theory, where we are going to compute the probability of a particular event. We saw in the first lecture that an event is basically a subset of the total sample space of some random experiment, and that the random experiment is basically any well-defined procedure that produces outcomes that could not be perfectly predicted in advance. As a particular experiment, in this particular lecture, we are going to consider the flip of a coin 2 times in a row. So we have a random experiment which is basically the flip of a coin two times in a row. So the corresponding sample space, so the set of all possible outcomes, contains 4 different elements. Sample space, let's call it S for sample space. It can be either first time heads and second time heads, so 2 times heads, first time heads, second flip tails, first flip tails and second heads, or 2 times tails in a row. As a particular event in this random experiment, we can actually look for the subset where we obtain at least 1 time heads. So let's look for particular events. Let's call this particular event A. So basically A is composed by 3 different elements. So we are looking for elements that contain at least one time heads. So basically it's the first one here. So heads and second flip heads as well. We could have like first heads and then tails. Here we have at least 1 time heads. The other one is tails and then heads, also at least 1 time heads. And that's basically it. The other particular event that we can actually look for is the one where we have 2 times tails in a row. So let's call this one B. And B has only 1 single element. It's basically this one here. So tails for the first flip and tails for the second flip. Now, as an additional step, we can actually ask what is the probability of obtaining the event A. So obtaining at least 1 time heads while flipping a coin 2 times in a row. So let's look for the corresponding probabilities. So probability of A obtaining at least 1 time heads. Well, this is actually pretty easy because it basically boils down to counting experiments. So basically we have to count the elements inside our different sets. So probability of obtaining A is the number of the set of elements of the set A divided by the total number of the total sample space. So number of S. For A we have 3 different elements, 1, 2, 3. So we put in here 3, and the sample space contains 4 different elements. So here we put the 4. And obtain 0.75 as probability, as corresponding probability to the question of what is the probability of obtaining the event A. Let's look for the probability of the event B. So what is probability of B? Well, we actually have to do this very same exercise. It's again a counting exercise. So we put on here the number of elements contained within the subset B, or the event B, divided by the total number of elements of the sample space. So this time for B, we basically have only 1 element. And we divide this by the total number of elements contained within the sample space. So 4 again. And obtain as probability 0.25. Yes. So that's basically it for the second lecture. Looking forward to seeing you for the next lecture, where we are going to consider an additional example and work out again the probability of an event.